Hi folks, Mr. Long here. I'm going to do a really quick overview of geometry properties to help you work through some questions. This is a very quick overview and a very general overview, but the first thing we need to deal with is triangle interior angles, or internal or interior angles. And you probably remember from grade 7 and 8 that the sum of triangles that are the angles inside a triangle adds up to 180. So here's an example where we have one angle that's 50, one angle that's 40. Right here, that's 50, that's 40, and this is a right angle denoted by the box, and that is 90, which means they add up to 50 plus 40 is 90, and 90 is 180 degrees. So, by the way, exterior angles are always 360 for any shape, but we can deal with that a little bit later. So here's an isosceles triangle that has an oblique angle right here, larger than 90 degrees. So if you look at this, it's 140 degrees. So we've used up 140 out of the 180, which means we have 40 left over. And because it is a isosceles triangle, we need to distribute that 40 degrees between those two. So we could call that x, for example, and x, and we would know that two x's are worth 40, and we would divide by 2, and then x would equal 20 degrees. So they're each 20, 20 there, and 20 there, because it's an isosceles triangle. Okay, so 20, 20, and 140, if you add that up, 20 plus 20 is 40, plus this 140 is 180. So in fact, yes, it worked. Okay, let's go to the next page. I encourage you to pause and write examples down as you go through this. Just some real simple definitions. Complementary angles are right angles that add up to 90. So in this case, y would equal 90 minus 40. Y would be 50 degrees, because those two have to add up. And then in brackets, well, we always have to give a reason with geometry. So you just might put COMP for complementary. Just when you're doing questions, like complementary, like in a bracket, like so. On a test, you'd write the full word complementary. Supplementary angles are angles that add up to 180, and that comes from the notion of half of a circle, because a full circle is a 360. So half is 180, and then the other half there is another 180, of course. So if you look at this one, I've got those two angles there add up to 180. They form a half circle. So x is going to equal 180 minus 140. X will equal 40, and then I would write SUP for supplementary. Okay, so complementary, the only way I remember it is the word complementary comes before supplementary in the alphabet, and 90 comes before 180. Now, another way that people remember it is complementary. It's right. It's always right to be complementary. So complementary have a 90-degree angle, which is a right angle. So it's always right to be complementary. But I always remember complementary before supplementary, 90 before 180. What happens with shapes that aren't just three-sided, like a triangle? So if you look, it's a really neat thing. It's really quite easy. Every time you add a side to a polygon, polygons are shapes that are closed with straight lines as their sides. So let's add, we start with a triangle, we add another side. So now we have 4 sides. Basically what we're doing is we're adding a triangle each time. So this has a 4-sided shape can fit 2 triangles. Therefore, it can fit 360 degrees internally. And then if you have a 5-sided shape, what you do is, if you go to one vertice, and you do like so, So now you have three triangles, 180, 180, and 180. You add that up, 180, 180, 180 is 540 degrees internally. So the question is, what happens if you have a 10-sided shape? A 10-sided shape would fit 8 triangles times 180 per triangle, right? So a shape will always have two less triangles than the number of sides. So a 10-sided shape will have 8 triangles, and each triangle has 180. So that's the way I remember it. If I know that if I'm looking at a 12-sided shape, for example, it will fit 10 triangles, and each triangle is 180. So that's the way that works. Okay, add a side, you add another triangle. Parallel lines or transversals. So we have 3 basic types, but the key thing with a transversal, which is this I know is also grade 8, it's when you have, and I'll just maybe mark this on here. So you've got a line here, and then a line to that is parallel, and they can go, by the way, I'll just draw one up here. You could also have parallel lines like this. They don't just have to be side to side. They can also be diagonal, vertical. We just often look at them this way. So this is meant to be 140 degrees right there. The interesting thing about it is in a transversal, you only need to know one of the angles, just one of the angles. Because if you look, this is 140 here. Opposite angles are equal. That makes that angle 140. And then, of course, you also know that these two angles here to here add up to 180. So that's going to be 40, and then the 40, that'll be opposite. And then the nice thing about these is that this intersection up here is identical to this one. So I can just copy it down. 140, 40, 40, and 140. So there's some patterns we need to know. Let's look at co-interior first. So that's co-interior, the C pattern. So the co-interior angles are like these. Okay, they form a C, a frontwards or backwards C. And notice it says interior. So inside. And so angles out here are outside. Angles like the 40 and the 140 here are inside. So they form C patterns. And they add up to 180. So co-interior are supplementary angles. They add to 180 and they form a C pattern. Alternate angles are the Z's. So there's a Z right there. So the Z can be external or it can be internal. So the Z pattern. In the Z pattern, the angles are equal. Okay, and that's alternate angles. Finally, you have corresponding angles here, and that is the, I think I've written it down there, it's the F pattern. So what you'll see there is this, and they're equal. So there's your F pattern there, and so you look at above the line, below the line, below the line. So there's 40 and there's a 40. But it forms that nice F pattern. The F pattern can be forwards or backwards or turned on its side as well. Okay, those are corresponding angles, and they are also equal. So in a transversal, you have 3 types of lines, or of angles rather. You have corresponding pairs of angles. You have co-interior pairs of angles. They add to 180, and you have alternate angles, the Z pattern, which are equal. Okay, folks? So you can go back over this later. I know this is a long video. Okay, here's an example to try to tie everything together. So what I'm trying to figure out here is X, this Y, and this X. And the only information I'm given is that this top angle right here is 30, and that this angle right here is 50. So the first thing I would do is I would go to the opposite angle. I try to fill things in as much